Welcome to SciShow Tangents, the lightly competitive science knowledge showcase. I'm your host, Hank Green, and joining me this week, as always, is science expert Sari Riley.
Hello.
And our resident everyman, Sam Schultz.
Hello.
I have an important question to ask. And it's a question that I've begun to interface with as we enter into, the sort of, 200,000th century of humans. How big is too big for a sandwich?
Oh.
I think that too big for a sandwich is more than twice as much as I can eat in a sitting. But up to twice as much as I can eat in a sitting is a perfect size for a sandwich, because I love a moment where I'm like, I'm half done with this sandwich, but I'm done with this sandwich because future me gets a whole sandwich.
I think the shelf life of a sandwich, that is a rewarding feeling. But then when you come back to the sandwich, it's not as good as it was the first time. It's just like too goopy. So I think a sandwich is perfectly sized when it's exactly the right size to eat in one sitting. A little too much more. And you're like, ooh, on my belly, but I have so much good sandwich in there.
Mm-hmm. There is an intermediate bad sandwich size in there where it's just a little bit bigger than I can eat in one sitting. That's the worst size for a sandwich.
That I like. Is when you're like,
it's a little bit bigger than you can eat, because then you eat too much.
Mm-hmm. And then you're like, I was a bad boy.
You like a little tummy ache?
Uh-huh.
Yeah.
and then you have a little nap, and then you're like, now I'm back to perfect sandwich level.
Well, I think, and maybe this is me growing up on the Scooby-Doo cartoons. I think a comically big sandwich is just fine.
As big as it can get.
If you have a giant piece of bread and a lot of toppings and can make a really big sandwich, all you need is a couple more friends or the ability to dislocate your jaw like Shaggy and Scooby-Doo to just shove it in, have your head expand to the size of the sandwich and then swallow it.
That's basically what I do to a Jimmy John sandwich. Just go in whole.
It sucks when a sandwich is too big
vertically. Yeah.
So I don't know why we're doing this. Is only for aesthetic reasons that we do this, and it's been a huge step backward.
So I guess too big for me. Length doesn't matter. You could have the longest sandwich in the world, and I'd be happy because you just find more people to share it with. You slice it up. So everyone has a chunk of a baguette. But you're right about height. It has to be narrow enough that if you compress it down, you can bite without scraping your mouth. Because I hate a mouth scrape.
Oh, the bread can't be too sharp also. That's true.
The bread cannot be too sharp because I'm got baby mouth and I do not like it when my soft palate gets scratched by a really hard bread.
Yeah, whereas I'm like a 43-year-old, so it's just leather in there. I can eat anything. I'm just having Captain Crunch dry. Every week here on SciShow Tangents, we get together to try to one-up, amaze, and delight each other with science facts while also trying to stay on topic. Our panelists are playing for glory and for Hank Bucks, which I will be awarding as we play, and at the end of the episode, one of them will be crowned the winner. Now, as always, we introduce this week's topic with the traditional science poem, this week from Sam.
For the first time in a long time, I've written myself into an embarrassing position where I'm going to have to sing a song.
Oh, yeah.
Wait, I'm loading up
these.
Oh, God, I'm so excited.
Listen up, here's a story about a little color that's known as blue. And it's not red, it's not yellow, it's another color called blue. If you look inside and outside, blue the sky, there's a blue robin egg and a blue peacock. And some things are just blue out there, like sapphires and some bodies of water. 'Cause sometimes things are just blue. Here we go. They're blue, something's blue, it's the sky. And there are probably blue flies, blue when you say goodbye. And you can have blue eyes, and if you need to know why, some things are blue 'cause of dye. There's also blueberry pie. They're blue, something's blue, it's the sky. And there are probably blue flies, blue when you say goodbye. And you can have blue eyes, and if you need to know why, some things are blue 'cause of dye. There's also blueberry pie. That's all I'm doing. I can loop that one around.
That's topic for today is blue, the color blue, and also possibly the emotion blue. And Sari, I bet scientists just went ahead and defined what blue was.
Yeah. Much like the green episode, we got the blue. As we work through the colors, we'll have a definition for all of them. And everyone waffles a little bit on what exactly the cutoffs are between colors, but roughly speaking, blue light, the color blue, has wavelengths between about 450 and 495 nanometers and frequencies between around 620 and 670 hertz. So in the spectrum of visible light, the wavelength / frequency that falls between those ranges is the color blue.
And it is a subjectively experienced also experience.
Yeah.
I don't know what blue is like for you, but I'm guessing it's roughly the same as what blue is like for me.
I think it's got to be exactly the same, right?
I don't know. We don't know, Sam. We've never had one person go inside another person, so we can't know. My blue could be orange. You'd be like, oh my God, Hank thinks that pumpkins smell like tuna.
But then how would they make scented candles that smelled correctly?
It's about the experience.
I
just love tuna smell the way that you love pumpkin smell.
Okay, whatever.
But you're right. Probably everybody sees the same blue.
It probably comes down to like the subtle differences, like how some people are better at those color tests than others of like range all these hues in order from like whatever the RGB code is along a spectrum.
Right.
And there's a lot of pseudoscience about the color blue. At some point, the BBC in a documentary presented an experiment that never happened, which is that a Namibian tribe called the Himba, they acclaimed that this tribe of people is completely unable to distinguish what Western society calls blue and green shades that seem like quite distinct. And it was just completely made up. Really, it was like a reaction time experiment where they had a color wheel with different shades of blue and green, and the participants in the study had to pick out which one was different. Like of, I don't know, like 10 squares, 9 of them were the same, 1 of them was different, and it was a little greener or a little bluer. And the reaction time was faster when it was all shades of green than when a shade of blue was introduced, but it's not that they couldn't tell it apart altogether.
Then there's that thing about like blue wasn't always real. Like ancient Greeks couldn't see blue or something like that. You know what I'm talking about?
I think that's kind of what Sari's talking about, where there's like, if you don't have the language for it, do you see it or do you just like call it? Because there are things like that where there are two things that are close together and in like one language they just like call everything yellow even if it's orange, because they don't have orange. But they can still tell the difference between the colors. But Sari, is there any evidence that you actually kind of start to see different if you have more language around color?
Not that I can detect. Yeah. And like maybe that's the experience, like the reaction time. You can notice differences better if you have the language to describe it. But like you said, in a lot of pre-modern languages, like words for green and blue were fairly interchangeable, where like sky, ocean, grass were all the same-ish word because they fell into that part of the color spectrum, and like greenish blue. And a lot of the pop psychology examples of, I think this is called linguistic determinism. So like it's getting at this idea that if you have language that is more precise and you have to notice the differences between things, then your brain might be a little bit different. But my understanding is that you can notice the differences between things. Like even though we call everything snow, or like we start to get to like slush at some point, we can still, with more adjectives and with more time and attention, tell different types of snow. Like when it's good skiing snow, and when it's good snowball throwing snow, and when it's like gross and muddy and yucky and things like that. Even if we just call all those things snow. And even though we call a lot of different things blue, we still know that the sky is a different color. than the deep ocean, which is a different color than a butterfly wing, which is a different color than a flower.
Do we know where the word blue came from? Because it's great. Blue.
It's a fun one. All the color words, they really nailed all the color words. Good, I think.
Yeah. Oh, a little on the fence about orange.
I like orange.
It's a sort of ridiculous thing to make me do.
With your mouth?
Yeah, it's just like, do you have to tell me what color a basketball is, and I have to say orange. Ridiculous.
I think that's a little bit your fault, because you could say blue really, really bad too if you wanted to. Blue.
That's fun.
Yeah, okay.
Orange.
That's kind of fun. Sounds like you're honking a big truck. Orange. But blue is weird of the color words in English because it is the only color word that didn't carry over from Old English to Modern English. In Old English, blue was Haywin with various different spellings. But around the time of the Norman conquest, when the French got involved, they were like, we've got this word, bleu. And that took over in English language.
It does sound very French.
It had a lot of different meanings, and this is, I think, where some of that color discussion of like, blue didn't mean blue, where the word blue in French, it sounds the same to my little dumb brain, can mean like discolored or like bruised. It can mean dark, like a dark ocean, or it can also mean like golden or fair-haired or things like that, like luminous. So there were a lot of meanings encapsulated by this one word. And then over time, I think we just specified that it's like, okay, blue is this particular color. It doesn't mean really just shiny things or dark things. It means the thing in between green and purple on the color spectrum.
What? Why?
Why was it so many things?
Yeah.
I don't know. Ask the French. Middle French, I guess. The Anglo-Normans, the Norman Conquest.
Dead French people.
Yeah. Practice your necromancy.
Gosh, there's so many questions I would ask. There's that scene in the Dungeons and Dragons movie where they're getting people up from the dead and they're asking them questions about how to find the MacGuffin or whatever. And I'm like,
that looks fun.
But like, if you could do this, can you do it to like dinosaurs? I want to ask a dinosaur 3 questions. It's like at the Natural History Museum doing necromancy on dinosaurs. Oh, somebody write this short story.
Yeah, Sue the T-Rex, ready to ask, but you only get 5.
This is just Night at the Museum, guys. They already made this.
No, but like dark. Because in order to bring it's a life for a life. So to ask the question, you do have to murder someone.
Squish a little bug.
Squish a little bug. Yeah. Thanks for saving me, Sam. All right. And now that we understand that fairly well, we're going to enter the quiz portion of our show. So when you think of worms, you probably conjure up images of wiggly little pink worms digging through soil, but it turns out that worms have interesting relationships with the color blue. So for today's Truth or Fail Express, we're going to be digging into the truth of worms and blue. And I'm going to tell you some blue wormy tale, and it's up to you to figure out whether or not I'm telling the truth. Story number 1. If you ever wanted to see a worm glow blue, simply waiting for the popular lab model C. elegans to die and then shining ultraviolet light on it will do the trick. Gut granules will shine blue as the membranes that encase them break open, letting them spill from the intestine and through the rest of the worm's body. Blue gut granules. Is it true or false?
I've heard a lot of this story before, I think, but I feel like I've heard Deboki talk about, because she talks about these freaking worms all the dang time.
That's Deboki, just a little worms.
That's also the entire institution of biology. Can't have to shut up about these worms.
I think it's true.
Okay, Sam thinks it's true.
I think it's false. I think it's a different worm. I think as much as C. elegans is talked about, but
it's not. We only know about one worm, Sarah.
That's it. All other worms as mysterious.
Boring. That worm's boring.
As old French people.
Worm. So they weren't sure for a long time why they glow blue under UV light when they're dying, because they only do this when they're dying. One hypothesis was that there was a waste product that was found in aging mammalian cells, but it wasn't clear why it would show up in C. elegans. But in 2013, researchers found the source of the blue was actually a molecule called anthranilic acid, which is found in the worm's guts. And as the worm dies, the organelles burst open and release this acid, which then diffuses through the body, and they become special blue glowers. But only
in their last moments. Yeah. It's their ghost.
It's their soul leaving their body. All right, story number 2. Another way to make a worm glow blue is to threaten a marine parchment tube worm so that it makes its patented glowing blue mucus that can glow for several days. When scientists investigated how the mucus is able to last so long, they found iron complexes that are able to power the blue light. That's amazing.
That's
if it's true.
Very cool.
I don't know why that's amazing. So I'm going to say it's false.
Sounds like that seems boring, and I don't know why anyone would care about mucus that glows for days.
Iron compounds.
It's like a battery.
I think it's true. I think this is probably one of those geothermal weird guys, and so they just want to make a little nightlight for themselves.
Well, parchment tube worms make glowing blue mucus when threatened, and that glow can last up to 72 hours, which is much longer than bioluminescence found in other organisms. So scientists wanted to understand why, because that mucus is outside of the worm's body and can't rely on metabolic processes for power. And in 2020, researchers reported that the mucus was powering itself with an iron storage protein called ferritin, which releases iron ions when it's stimulated with the blue light, which can then make the mucus make even more blue light, creating a very long-lasting blue glow, which is so freaking cool. So congratulations, Sari. I don't know if these are the ones that live at the hydrothermal vents, though. I don't think they are. Little known fact, they also have a little blue house with a blue window.
Yeah.
And the streets and trees are blue as well. And they have a blue Corvette. Every one of them gets their own small blue Corvette.
They're a very advanced civilization down there.
Civilization. Our final story is of C. elegans. Again, because they don't have eyes, and they also don't even seem to have cells that are capable of detecting light. And yet, they are able to avoid the color blue, a skill that they put to use in avoiding toxins produced by mats of blue bacteria. True or false?
Again, I feel like I've heard Deboki tell most of this story about something that wasn't this. So I'm going to say this is false. They don't have eyes and they can avoid something, but it's not that.
I want to say it's true. I know there's like cyan bacteria or algal bloom mats, which I think is close enough to blue to count. So I'm going to say true.
Well, indeed, it was true. They were all true. So
wow, triple true. What the heck?
Can't game it. Sometimes we'll have all of them be the same. So the bacteria Pseudomonas, I don't know.
I think that should be your new Microcosmos hosting strategy.
That show is so good, except for that part. It's like, I don't know, man. Microcosmos is hilarious to host because sometimes the things we are saying, we're like the only people who have ever in public said the word.
That happens on SciShow a lot too.
Makes sense.
And it's just like, I don't know. The hosts are like, what do I say? It's like, no one's ever even tried.
You're defining the pronunciation of this word right now. Like I'll ask and they'll be like, I don't know. I've only ever seen it written down. And I'm like, but you study this organism. And they're like, yeah, we don't say its name out loud.
We don't talk about it that
much. We don't talk. Science, we don't talk.
Yeah. What do you think? We're on the phone with each other? So this bacteria, Pseudomonas aeruginosa, produces a toxin that the worms want to stay away from. And it's also the bacteria is a bright blue color. In 2021, researchers reported that if they turned off the lights, C. elegans were slower to run away from the dangerous bacteria than if the lights were on, almost as if they could see the bright blue bacteria, which was surprising, given that these worms don't have eyes or even opsin receptor genes that could help them visualize blue based on anything that we know. So
What?
the researchers tried various combinations of pitting the worms against the bacteria in the light and dark and against mutated versions of the bacteria that are beige but still toxic. And they found that when the worms faced off against the beige bacteria, the lights didn't affect how fast the worms ran away from the danger. So even though it's not the toxin they were sensing, it's like it's the color somehow. They also found that the worms avoided the isolated toxin when it was mixed with blue pigment. So based on the results, the researchers hypothesized that the worms were somehow detecting the ratio of blue to amber light and avoiding the toxic bacteria. And while researchers found 2 genes that might be involved in this behavior, the exact mechanism of how the worms are identifying blue and responding to it is unclear, and that is exciting.
They see with not anything that we've seen before.
They don't
no
know.
eye.
They can see, but we don't know how. That means anything could be seeing.
This is when people talk about like alien life that operates in a totally different way from us that we can't even fathom. This is it. It's like, how are you detecting blue? We only know so many ways.
Whenever I hear about some weird fact like this about C. elegans, it reminds me that there is some weird fact about every organism.
Yeah.
Because we know so much about C. elegans. But only because they're good at living in the lab and they're fun to study and we studied them a lot.
And it took us a long time to figure out that one thing about them too.
Yeah, we were just like, well, they're running away from blue stuff, but they don't have eyes. So listen up. Here's the story. We're going to go take a break. We'll be back for the fact off.
SciShow Tangents is brought to you by Rocket Money, a personal finance app that finds and cancels your unwanted subscriptions, monitors your spending, and helps you lower your bills all in one place. Look, guys, I got to get all this in one take, or our editor, Seth, is going to be mad at me because editing just one person talking is not very much fun. So here I go. If I mess up, I'm just going to keep rolling, baby. These days, it seems like everything is a subscription, doesn't it? There are streaming services, sure, but there are subscription services for software, dog toys, toilet paper, printer cartridges. It's getting weird and wild out there, folks, and it can be easy to hit a point where subscriptions are draining your wallet. And some of the things might be things that you don't even remember subscribing to in the first place. In fact, 80% of people have subscriptions they have forgotten they even signed up for, but Rocket Money can help you with that. And once it's done helping you sort out your subscription mess, it can do so much more. You can monitor all your expenses in one place, get custom budget recommendations based on your past spending. They'll even send you notifications when you've reached your spending limits. Rocket Money has a certified money dummy like me looking at my spending, which is genuinely, there we go, pretty impressive because I'm extremely bad at looking at my money. Who would ever do that? With over 3 million users and counting, Rocket Money customers have saved an average of $720 a year. Wow. Stop wasting money on things you don't use. Cancel your unwanted subscriptions and manage your money the easy way by going to rocketmoney.com/tangents. That's rocketmoney.com/tangents. rocketmoney.com/tangents. Nailed it.
All right, we're back. Sari has 2 points. Sam has 1, and we're gonna figure out who's the winner with the fact off. So each of you guys got a fact to present to me in an attempt to blow my mind. And after the facts are presented, I will judge and I'll award the Hank Bucks any way I see fit. To decide who goes first, though, I have a trivia question. In 2009, an Oregon State University graduate student named Andrew Smith was working on developing a new electronic material. Instead, he accidentally created a blue pigment that has since become known as Oregon blue, mass blue for the professor whose lab the pigment was found in, or YInMn blue. This last name is based on 3 of the elements that make up the pigment: yttrium, indium, and manganese. But there's one more element in YInMn blue that's not credited in the name. What is the atomic number of that forgotten element? And we'll get you by who's closer.
What is the atomic number of anything?
But it's going to be between a 1 and 100. I'll just tell you that. And it's not going to be 1 or 2.
It's not going to be 1 or 2. And it's probably not going to be above like 70.
Very unlikely. Yeah. It's not going to be super weirdly radioactive.
Yeah. It's not going to be like one of the new Nobelium or whatever.
It's not going to be one of the ones that only exists for a microsecond before.
Yeah. It's like, we found out how to stabilize it, guys, and it's in this blue pigment.
It's blue.
Yeah. That would not be the story that people would write if we wouldn't care about the blue pigment if we could stabilize one of the
you guys are friggin' dorks. What's like
that is the point.
How about I'm gonna guess first, and I'm gonna say 30.
Okay. I'm gonna say 36. I don't know. I don't remember the periodic table well enough anymore.
It wouldn't have helped. I don't think it's oxygen. It turns out, so it's magnesium oxide is tagged on to the end there.
Wasn't worth mentioning though. Oxygen.
No, well, it's not. I mean, kind of. Yeah, it's just doing its little job, and it's 8, so same as the winner. But do you want to know more about YInMn blue?
I would love to.
It was the first inorganic blue pigment created in more than 200 years.
Wow.
The last one was cobalt pigment. It's very stable and non-toxic. In comparison, cobalt can be poisonous in large quantities, and it also can fade. In 2017, Crayola created a new blue crayon inspired by the pigment, though it didn't actually use any of it. The color it replaced was dandelion yellow, and it's called Bluetiful. The EPA approved YInMn blue for use in industrial coatings and plastics in 2017 and for consumer use in 2020. So exciting.
Wow.
We've got more blues in the world, y'all.
Great discovery, Andrew Smith.
It's so blue. You should look it up.
That's the bluest dang
this
blue I ever
bowl
seen.
Full of it is almost upsettingly blue.
Do you want to eat it? Because I kind of do. I know it would be very bad for me because it's so metal.
Well, apparently it's non-toxic. Must be very stable. I kind of want to like rub it on myself. But
then you could join the Blue Man group. We could be the new Blue Men group, but just YInMn.
The YInMn group. We're the YInMn. The YInMn.
Yeah.
We're the YInMn men group. And we don't play drums, though. We just sort of make jokes.
Yeah. We just all get up on stage.
They don't talk at all. We talk a lot.
Yeah.
That's the difference. We get really tired halfway through because it's just a lot to be up there for that long.
It's just a lot. We record at 4:00.
Yeah.
I don't know. I don't know why. I don't know how we expect ourselves to do this. Anyway, Sam, you get to go first.
When you injure your spine, one of the really nasty initial side effects is that the area around your spine swells up, which can cut off blood, kill cells, and mess up a neurological function even more than the spine injury already did. You can do things like give patients steroid injections to curb the swelling, but it doesn't really seem like it works all that well. So basically, spinal damage is bad, but then it swells up and it kills cells and makes things worse, and there's really not that much that anybody can do about it. And the reason for that swelling is because your body releases a bunch of ATP, a chemical that I vaguely remember from high school biology that I guess gives cells energy. It's the powerhouse of the cell, right? Okay, anyway. There's so much ATP at the site of a spine injury that the cells there get stressed out and die because they just have too much energy. And I guess that makes everything swell up. I'm not really sure how swelling works, but I guess maybe like a bunch of dead cells make stuff swell up. Anyway, ATP is the culprit. But this team of researchers had a thought. If you could block the ATP cell receptors in the damaged area, maybe the cells wouldn't die and the swelling wouldn't be so bad. So they fired up the old lab equipment and they did some tests, and guess what? It worked. They injected oxidized ATP into test rats and it stopped the swelling, which is great. But what's not great is that for, I think, a variety of reasons, oxidized ATP injections couldn't be used in real-world human medical applications. And one of those reasons was the whole injection part. So according to the researchers, doctors don't really like to inject things straight into damaged spines. So their idea worked, but it was not practical. But then they thought it might be practical if they could find an ATP blocking compound that could be delivered intravenously. And that's where blue comes in. So there's this blue dye called Brilliant Blue G that's already used in medical contexts, primarily used in eye surgeries, but it also just happens to block ATP. And it also happens to be like the exact same compound as blue dye number 1, which is a food coloring that makes all of our favorite blue foods like blue M&Ms and blue Jell-O and blue Gatorade. It makes them all blue. So I sort of wonder if doctors were like, we can't just say that we're using blue food coloring. So we got to think of another name for this stuff. And then they decided to call it Brilliant Blue G instead of blue dye number 1. So anyway, this stuff is really cheap, and even better, it crosses the blood-brain barrier, so it could stop all kinds of nasty brain and spine-based swelling. So the team injected some blue dye into rats with spinal cord injuries, and the rats that got the injections fared far better than the rats that didn't, up to the point that the injected rats could walk with injuries that totally debilitated the non-injected rats. And there is one side effect, though, and that the blue dye is a blue dye, so that the places that it ends up being injected turn blue. And if you're a tiny little rat, then you're going to turn into a blue rat for a little while.
Oh my gosh, they're very blue. They got these blue little ears and their blue little nose.
But they're feeling way better. They're just blue.
This seems wild. It seems wild that this chemical, so it's given intravenously for the therapy, and apparently we can eat it without it affecting our ATP at all, I assume. I can have blue Gatorade without having to worry about its bioactivity, which you would think we would have tested for.
Yeah.
It's a giant molecule. Like, it looks like a big old honker. My first thought upon seeing it is, I wouldn't want to eat this.
You probably ate it today. Do you eat a blue M&M?
It's possible. No, but I would like to. I did drink Gatorade today, but it was not blue.
I think we'd know by now if something bad happened because of it.
And if blue Gatorade cures spinal cord injuries, that's a pretty cool fact.
Yeah.
All right, that is very weird, Sam. Sari, what do you have for us?
So there's this really lovely grayish pale blue pigment called blue ochre or Vivianite blue, named because it comes from the mineral Vivianite. And it was historically used in art from various cultures, including indigenous peoples from the northwest coast of the United States, or in the 12th and 13th century in Europe. Artists used it as well. And like many natural pigments, Vivianite was mostly used by people who could find and harvest the mineral nearby. And this is where the fact off kicks in, because Vivianite forms under really specific conditions. When something dies and the phosphate in its bones or teeth or cells or whatnot react with iron in a damp environment. So chemically speaking, Vivianite is a hydrated ferrous phosphate mineral. And casually speaking, it's a crystal crust that forms on wet, dead things and turns blue when it touches air and oxidizes. And if you start poking around archaeological literature, you start seeing these blue Vivianite crystals in all kinds of papers. It's been found on human remains in crusty patches or discolored blotches from the lungs and skin of the Iceman Ötzi, the oldest known human mummy of a man who lived between 3350 and 3105 BCE, to the bones of U.S. soldiers who died in a plane crash in the 1960s during the Vietnam War. It's also been found on lots of animal parts, from the skin of a 36,000-year-old mummified Alaska steppe bison nicknamed Blue Babe, because its skin was blue, to clamshells and mammoth tusks and all other kinds of biological things. And it's even been found encrusting pieces of decaying wood or other organic stuff, because phosphorus is really important for life. In bogs or ponds or other watery shores that are near deposits of iron, either naturally occurring ores or from human-made stuff like weapons or armor. And on top of being a cool pigment for its rarity and association with dead things, Vivianite can both help and hinder research in different ways, which I thought was weird as I started digging into this. At least one paper blamed it for contaminating DNA amplification and analysis when samples were taken from human skeletons because it binds up phosphorus, while others used its presence to glean more context about the environment in which something died, because it'll be like moist and boggy or whatnot. So blue finds lots of ways to show up in nature. If not in life, then in whatever comes next.
Wow, this is weird. So when I Googled it, I saw these like beautiful, big structured crystals. But when it's showing up on decaying matter, it's like little pieces of Vivianite. But it happens a lot with decaying organic matter.
Yes.
Organic matter. Wow.
I think so. I think the name for Vivianite came from just this like UK guy who found it in a cave and probably found one of the bigger crystals. Mm-hmm. But it had been known as a substance, as like a blue substance and a pigment. So I don't know how much people actually like gathered the pigment itself from dead or decaying things versus finding stones of it and then grinding it up. But I think it's a mix of both if I had to take a gander.
That's so interesting. And they found it on Etsy. Etsy,
I don't know how to say it. Etsy? It's like the O with the umlaut.
Etsy, not Etsy, not the online marketplace. Could probably get some Vivianite on Etsy as well. See, that was a bit of a branding problem that we created with that particular mummified body. All right. So I have to choose between absolutely mind-blowing blue Gatorade injected into the spinal cord injuries of rats and absolutely mind-blowing minerals that selectively grow on decaying organic matter. And Sari's already in the lead. So I'm going to have to consider all those facts all at once. All those little pieces of data and just put them into my little calculator brain. Decide who wins the episode of SciShow.
I would love to look into your head and see if you're actually thinking about any of this at all, or if you're just saying that you're thinking about any of it.
I'm thinking about it.
Okay.
You're just thinking about your song,
math
Blueberry
equations.
Pie.
You know, I think that the Sam fact is so weird. I think it's at least +1 weirder than Sari's fact.
I was on a cold streak too. I needed this.
Sam can get the episode.
Thank you.
And I'd also like to dig a little deeper into it and see where we are with this research. Because I think it could make a pretty good TikTok.
Yeah.
All right, and now it's time to ask the Science Couch. We've got a listener question for our couch of finely honed scientific minds.
James on Discord asks, is there any truth to the supposed notion that blue is a more ideal color for social media platforms or streaming services to brand themselves with?
I mean, it's gotta be.
Because a lot of them are blue.
For one, there's just too many that are blue.
Yeah.
And two, it's just I think that we like blue. I think it's non-threatening.
Like Netflix is red, and that one's
Instagram
just too much.
is like kind of red, purple, pink, yellow now.
Yeah, they're trying to have it always. Threads is just black and white. The hot new social media sites lighting the world on fire.
Experience Threads. Yeah. That might no longer exist. That just everyone's ignoring now.
Could be gone by now. Yeah.
Because we record well in advance. Sari, though, is going to have a much better information on this because I'm just vibing here.
Yeah, I mean, you're vibing in the correct direction. I think that's your observation of social media at play. And honestly, I think a lot of marketing researchers are also vibing because the research here is, from what I can tell, thin. A lot of websites that like say blue is a great color or blue is a super popular color are usually pointing to one of two studies, from what I can tell. There is a YouGov survey conducted in 2014 in a total of 10 countries: the US, Britain, Germany, Australia, China, Hong Kong, Malaysia, Singapore, Thailand, and Indonesia. I'm guessing around 1,000 respondents per country, and found that blue was the favorite color of people in all those countries. Between 23% was the lowest in Indonesia and 33% in Great Britain was the highest, liked blue the most out of all the colors listed in the survey. And then the second one was a 2003 undergraduate thesis by a kid named Joe Halleck.
What do you mean a kid?
We just want to be clear. If you are under the age of 22, you're a baby, baby.
I just think it's funny that everyone is pointing to this undergraduate thesis from this guy who's now a grown man and probably doesn't think about... I did not look him up, so I apologize, Joe, if you're a fan of the podcast and are still like really into color psychology. But your website, great transparency on where you got your data and everything. His initial hope was to get 500 responses across the world. When he closed the survey, he only had 232 results, and nearly 80% were from the USA. Mm-hmm. And he asked people to associate colors with different words. And so be like, what color do you associate with trust? What color do you associate with bravery? What color do you associate with, etc.? Things like that. And so blue was the top answer for trust, security, reliability, and dependability.
Yeah.
It was the second top for high quality or high technology, with black taking the top for that.
Yep.
And he also found that blue was the favorite color of 43% of everyone that he surveyed.
Wow.
And so a lot of people point to these things and are like, people love blue, but I don't know. It's hard to survey a large amount of people.
Yeah. And I also feel like there's just like a weird, Like, do you even know what you implicitly associate with trust? Like, if you ask me, am I right about how I feel? I'm more likely to be right than wrong, but I'm also not. I wouldn't be shocked if I ended up being wrong.
I don't know. Yeah, people don't introspect into their biases as much. The other bit, there's a 2011 marketing paper called Exciting Red and Competent Blue, The Importance of Color in Marketing, that found that blue is linked to the idea of competence. And specifically, they used a brand personality scale from 1997. So there's this idea in marketing of assigning people personality attributes to a brand. And so this Akers scale includes characteristics like sincerity, excitement, competence, sophistication, and ruggedness, and tried to assign some combinations of those traits to various brands. And so this 2011 paper used this scale that became very popularized, I think because it's pretty pithy, and then generally found when they tested fake logos of various colors and then asked people to assign these 5 attributes and like the subcategories of them to them, that blue was associated with competence. And then also when they had desaturated logos of brands that already exist, then they found like reinforcing evidence. So that was interesting because it actually has to do with logos and people's gut reactions to those logos, both familiar and unfamiliar. But again, just like big asterisk on any of these things of like, what are people feeling? How do we quantify this? This brand personality scale is from 1997, and we've done a lot of psychology since then.
The whole internet has happened since then, and we've looked at apps and stuff, and like the 2 most blue apps are Facebook and Twitter, and those are the least competent apps in my opinion. So
because they don't have to be competent because you think they are because they're blue. Whereas Pinterest has to really focus on trying to look competent because everybody just implicitly, they're very brave. Pinterest.
Yeah. Very exciting Pinterest.
Very exciting and brave. So if you want to ask the Science Couch your question, you can follow us on Twitter at SciShow Tangents, where we will tweet out topics for upcoming episodes every week. Or you can join the SciShow Tangents Patreon and ask us on our Discord. Thank you to at Space Hikes, at Nicolese1, and everybody else who asked us your questions for this episode. If you like this show and you want to help us out, it's real easy to do that. First, you can join our Patreon at patreon.com/SciShowTangents and become a patron, get access to our newsletter and our bonus episodes. And don't forget, once we hit 700 patrons, we're going to do our Minions movie commentary.
Whoa! Guess how many patrons we have right now?
699.
We have 666. We got the nasty, evil number.
Well, we need at least one more patron.
To join, not to quit, even though both would work, but join only.
Either way. So please subscribe because we are tantalizingly close to discovering what's really inside all those minions. Is it piss? Yes. Second, you can leave us a review wherever you listen. That's very helpful, and it helps us know what you like about the show. And finally, if you want to show your love for SciShow Tangents, just tell people about us. Thank you for joining us. I've been Hank Green.
I've been Sari Riley.
And I've been Sam Schultz.
SciShow Tangents is created by all of us and produced by Sam Schultz. Our associate producer is Eve Schmidt. Our editor is Seth Klitzman. Our story editor is Alex Billow. Our social media organizer is Julia Buzz Bazzaio. Our editorial assistant is Debuki Chakravarti. Our sound design is by Joseph Tuna Medish. Our executive producers are Nicole Sweeney and me, Hank Green. And of course, we couldn't make any of this without our patrons on Patreon. Thank you, and remember, the mind is not a vessel to be filled, but a fire.
But one more thing. Salt is great at dehydrating meats and just as great at preserving human poop.
Oh,
in a 2021 paper, researchers analyzed the DNA and proteins in 4 old poop samples from the Hallstatt salt mines in Austria. 1 from the Bronze Age, 2 from the Iron Age, and 1 from the Baroque period. One of those poops, which was estimated to be 2,700 years old, had an abundance of fungal proteins from 2 specific organisms, Saccharomyces cerevisiae, which is brewer's yeast used in beers, and Penicillium roqueforti, which is the mold
I was
that
like,
gives...
nothing about this is blue.
Where's the blue? Well, it's there.
Sorry.
And the mold that gives blue cheeses their color and funk. So this is the first molecular evidence for humans making and eating blue cheese and ironate syrup. We found it in
a
poop.
long time ago.
Why are they crapping in salt mines so much? What's going on there?
Because they got to mine the salt.
You go where you are.
I guess so.
Yeah, especially if you had a lot of cheese, and that's like because
you drank a lot of beer, you had a lot of cheese.
Beer.
And you don't want to miss the opportunity. If you hold it, you could miss your chance.